So now I'm going to try to implement this. We are going to implement this invalidate TLB, and that's. Do we need volatile? I'm not sure if we need volatile for this. But we'll put it there. So this would need to be invalid page, I believe, and this takes just the address. So let's just call it address. And that means we have no inputs. We have no outputs. Our inputs are our address that we need to put to some register, I think. And that comes from address. And actually, I'm not sure about the. Oh, so it's parentheses. Right. Okay. That should be that. Let's give this a build. Okay. That looks good, I think. Is this function called anywhere here? Oh, it should actually be called on Quickmap. Yeah. So I am going to go and trigger a Quickmap. So kernel vmem.quickmap. So I need some address. So let's go for 14.0.0.0. This does not return anything. Actually, it does return a let's call it a const. Address is that, and then I'll do const value, or rather, yeah, let's call it value. This would be at pointer from int of address, and we are going to do kernel vmem dot quick unmap of that address. Actually, hold on. This never uses address, so we can just get rid of that. Yeah. This here, we need to tell it that this is a pointer to some U64, and then we are going to do this equals to 123, just to trigger any. So cast discards const qualifier Quickmap. Of course, this needs to be a variable. No field named Quickmap pointer entry instruct vmem. Okay. So instruct vmem. I believe that does a trick. Yep. Expected U size found memory via address. Okay. Expected U size found memory via address. So how does that go? Const entry pointer is pointer from int, rather entry address is actually never mind, we can just do bitcast here. I think that should be enough. Yeah, no. We also need to do as U64 whole shebang. All right, so this needs to be copied somewhere here. All right. Okay, so inv page. Okay, all right. So that means that this needs to be. Oh yeah. Okay. So in the NVL page, that should please invite operand for instruction. Does it need an immediate? Okay. Weird, but okay. Let's see here. Okay, so invalid opcode. So I guess this is when we call invalidate page, I believe. Let's check that. Let's make sure of that. So I'm not sure about this here. I'd like to do this, but let's first do something like so. So we could specify which register we want to write to. Let's go for R8, for example. And here just say that we have messed up with Cloud R8. Invite operand. Okay. Right. So this here takes a just an address, and it flushes the TLB that contains that address. So why is it whining about? I think that this should be fine. And here we are just going to say that we are writing to some memory, some random memory. Okay. It's kind of. So let's see here. Let's do something like this. Let's do something like this, maybe. Expected. Okay. Does not work. So let's call it address. Huh. Okay. Well, that's something. We still have the invite opcode though. So let's do LVM option with kernel 64.alf, and I'll go for the less. So here we'd like to find where we have our invalidate page instruction. Let's do this. Oh, there we go. So here we have what is this? Okay, maybe I went by a bit too quickly. So let's do something like this and grep for invalidate page. Okay, so we do have a byte pointer at R14. But does that mean that we now need to take the address of this thing here? Let's do this again. Pointer of RIX. I'm pretty sure we have the same thing again, but okay. Right. So, well, first of all, let's make sure that it's this invalidate TLB that causes the issue. So let's just remove it from there. Maybe go here to stud log info quick mapping, something like this, and then here we go for something like that. So I just removed the invalidate TLB from the Quickmap. Okay, so that's not the issue, I think. Something else was the issue then. Is it maybe this? So let's do stud log info quick mapped value at let's do something like this. Sure. Well, I guess we have no choice other than to debug this. So GDB, so target remote. Okay, and we'll break at. Actually, let's load kernel 64 elf for symbols, and let's break at I guess failable main. Forget what I called that. Failable main. Okay. Symbol. Okay, so that's not defined. So failable main. There we go. Okay, so let's continue. Okay, so let's break on main.zeg line. Let's say this one here, so 65. 65. What? What do you mean? No, line 65. So let's put another breakpoint at address. So this one here. Yeah, you know what? Let's just go step by step. So next. Okay. this is getting fairly old, so let's do this. Yeah, sure. Let's just do this. Oops. Okay, so let's go again. Target remote 134. Let's get the symbols from kernel 64 elf. Okay, and let's put a breakpoint on main.zig. Should have changed. This one here, 61. No line 61. I think I should build this with oops, there we go. Should probably do this to get good symbols. Okay, so let's try this again. Target remote 34, file build kernel 64 elf, and break at main.zig 61. There we go. Oh, right, very nice. So now we are going to actually, let's step it a bit further. Let's go to line 65. So main.zig 65. Let's go. All right. So here we are going to go into this. So step into that function. Okay, let's go. So let's go next. And does that cause the problem? No. Okay. So does that mean that we have already okay, so that means that this line here is causing the problem. The entry here. Okay. Let's try this again then. This time I'll go back here and do that. Let's add a breakpoint under vmem .zig at line 371. I think we should still be fine at this point. Okay, so we are not fine. All right, let's try this again. This time, try to be a bit more careful. So target remote K4. And I think we should still have the same breakpoints. Okay. So let's continue that. All right. So now we are here. So let's do kernel vmem. Right. Quickmap is still at 0. Length is 0. Oh. Huh. Is that the problem? Because it's still at 0, so that means that we still haven't initialized it to anything as of yet. Okay. Let's see here. So if I step into that function, just go for locals. Locals. Entry is whatever that is, and address is 1. What? Okay, so I think the first thing we've seen is that we've never set values for these two fields. They still have the same 0 values that we've set them up with at the start. So let's go ahead and do vmm quickmap dot start is actually quickmap start. Quickmap start and vmm quickmap dot length is quickmap length. Same goes here. So vmm dot quickmap btn3 dot start is quickmap bt entry start. And vmm dot quickmap pt entry dot length is quickmap pt entry length. Okay, so let's build that first. So expected type v address found u size. Okay, that's fine. So that needs to become so bitcast, since that's a U64. Same goes here, so this one goes to bitcast. And it should already know the type, I believe. Okay. So that's that. Let's get rid of this for now. Let's see where we go. Oh, there we go. So now we don't have the issue anymore. Right, so let's actually do something here. Let's do v.start is 1, 2, 3, and make sure that it's not getting we are not getting a page fault. So this one here, we need to be something like that. Unable to resolve. Okay, that's wrong language. Uh, 7b. And what is 7b? Sorry, 7b is 1, 2, 3. So that's pretty good. So we have actually quick mapped our address. We've written to it, and then we've quick unmapped it. Let's just make sure that if we now try to write to it again, this time we do this, and this time we actually do this, which is the more sensible choice. And here we just do that. Let's see. So that means that the memory you've chosen is actually already accessible. So let's go a bit further down the memory. Let's go to 299 FF and 1, 2, 3, 4. That's still mapped somehow, or are we not invalidating the TLB? Can also be a valid issue. Actually, let's do something else. Let's try to do something else. Just going to look at my page map here. So I know that the end of my page map lies somewhere here. So we are going to copy that, and then we are just going to paste that somewhere here. Do a bit of that, and maybe do this minus that. Let's just make sure that we can actually get errors. Okay, it's actually pretty weird, but let's for now do never mind. I'm going to need to do something like this. And I'm going to need to do log.info Quickmap. Let's do something like this. Points to this address. So this one here would need to be the Quickmap, which is I guess just this Quickmap address. Yes. And then we need to do entry.getAddress. Entry. Okay. And here now that we have that, we can put that on the nmap too and see where we go. Okay, so that means that this actually points to that address there, and we've read that value from that address. Okay, so here's what I'm going to do now. I'm going to go back to main, go for one address I know is mapped. So for example, you can go for the same address we had before. And we are going to get the value of that. And then we are also going to get the ID mapped. And this would be at pointer from int of that. And this, of course, is a pointer to U64. And we are also going to do that. And this would be v-id mapped dot deref that. Since that address is actually identity mapped, we know that it's going to be correct. And if we had written the same value to that again, we'd have the new value twice, basically. Whereas here we have 0, which is not good either. So let me do this, put this up here, and add this to, oops, and add this somewhere here also. So v id mapped. Oops. It's a problem here. Oh yes, of course. So I'm not liking that this gives us 0. Okay, maybe I've messed up something. So let me go to here. Okay, so here we have Quickmap. So this is the page. This is the page where we have our Quickmap, and this is the actual PTE 5000. And here we are actually mapping to 5000. So I think we have a problem right about here. So this would need to be this dot quickmap dot start, I believe. Yeah, this needs to be the same. So vmm dot quickmap dot start. Right. So let's try this again. So expected pointer found v address. Okay, that's fine. So as u64, oops, forgot something. Bitcast that, and then we need 2 of those. And same goes here. So as u64 add bitcast, and then we need 2 of those. Expected pointer found u64. Oh. Then we don't need this anymore, I guess. Fixed. Okay. Let's see now. Okay, so now we have the inverse problem, I'd like to say. We are writing zeros and we are getting back zeros. That's great, but not really. Expected this value here to be written to where our pointers are pointing. All right, so let's try to debug that. Okay, so here we are. Let's go next. And next again. And this time, if we print address, we should, as hex, we should have the first actual entry. If we print the value at address, cannot access memory. That's bad. Okay. And if we try to print VID mapped, that's all right. And if we try to access its value, it says it's 0. Now if we go next, and then try to do the same for V. So V is that value. And then if we, so it's not correctly mapped yet, V. So, okay, so that means that this here would just do nothing because we cannot access that memory. And yeah, so if we try to do this again, we still cannot access that memory. And if we do this, 0x, that it's still 0. Actually, let me just do something like this, mapped. Let's try to do this for now. Okay, so now let's first of all do print of VID mapped. Of course, we need to deref that. So that gives us our value. So that's correctly mapped. Now let's try to do the same for V once we have it. So now we should have V. So print V should point to the correct address. And now if we do that, and it's still not liking it. So did we mess up when we mapped our quick maps? So 15B000. Yeah, so that's the address we actually tried to read from. Are we probably not correctly inviting the TLB? Some reason. Okay, so here we take the address, which is the Quickmap address, the correct one this time. and that's what we are trying to invalidate. I know maybe we should do something like this. Right, so let me just add a breakpoint at line 70. Right, so here we can go ahead again and print that, print the value to that, and we still cannot access memory. That's a problem. Okay, I think I've got an idea where things went wrong. So this page here is the start of so let me go to UEFI bootloader, because we did something here and we forgot to do it on the other side. And that is, where is it? There we go. So this line here is the thing we forgot about. So here we have our PT address point to here, and as we can see, where was it? PT address. Yeah, there we go. So we are at this address here, right? Oops. So we are not at the start of the page. We have an offset into that page. So these 12 bits here are our offset. That offset is the actual page table index, except that we have never used the page table index in our vmem code to write to the correct entry. We just assume that this entry, the first one, is the correct one, which is not really the case. So let's actually compute the correct entry this time. The way to do that is we are going to create a v address from the Quickmap start. So let's get this one here up here. This one will become a v address. So actually, it's already a v address. So let's do that. That's a v address. We are going to get the page table map from that v address. So we are going to do a bit of so we are going to need to move this by size of one page table entry. So page map mapping dot entry times oops. So this one here would need to be a plus, and this one here would need to be the Quickmap address dot page table index. I believe that's how it should be. And now if we so let's think about this correctly now. Let's print, first of all, let's print the pointer to entry that we just wrote to, just to make sure that it's the correct one. And we'll get these two over here. This one is needed now. And we can also go ahead and put the pointer there to entry, of course. Now with this, I believe we should at least have the correct thing to work with. Incompatible types v address and u9. What's this? Oh, right. So that's true. That is true. So how do we go about this? So we could just cast this as U64. Okay. No, actually, hold on. We actually needed this to be just that. And here we are going to remove those. Okay. That looks okay. So let's do that same here. Let's see where we get. So compile error format invalid X for V address. Okay. Format V address. So okay. Let's do this and also this. Let's go here, get that done there. Same goes here. And now let's create const quickmap address, which would be as rather a int from pointer of quickmap. Quick map. No, actually, this should just be a bitcast. Of course, we can tell it that it's a U64. Right. Okay. Okay. Now let's try this again. This time, we're hoping to have the actual value we're looking for. Right, so let's first of all take a look at what we get here. So we are expecting this value here, 121AD8 is the PTE we need to write to. So let's go continue here. And once it's done, let's go back here. AD8. Okay, that sounds all right because that's the same offset. That AD8. Where was it? AD8. AD8. That looks promising. So now let's do the usual thing. So VID mapped is that address. Let's do that. That's correct. Let's print V this time with that. And we can see that both of those addresses actually point to the same value. So now let's go next. Okay, so let's reprint this. This time it's pointing to the new value 123, and this one should also be pointing to the same value 123. So now, if we go next a few times, so here I'm expecting that to be correct. I'm just going to go ahead and quick unmap that. So now, if we actually go ahead and write to that address. I expect that VID mapped hasn't changed. Ooh. It did change. How about V? Okay, so V is not mapped anymore. But we still somehow could write to that value, which is kind of weird, but okay. So let's go here. 123, 134. Okay, so this behavior here is weird. because we have successfully this time unmapped this page. And actually, hold on 1 second. Let me just do something quick here. So if I just disassemble at address 0, it's 0. So, So for some reason, we did write to an invalid address. So our quick unmap still has some things to iron out. So we are writing flags, empty flags here, default values. That should be it should, in theory, just panic. Right. So are we not invalidating the correct TLB? That can be another issue. So let's, this time without having to debug this. Ooh, this time it's, okay, so this time we have invalidated the correct TLB, so we now have a page fault if we try to write to value, to v. Okay, so if we go back to main, let's, just before we do this, let's try to, so let's copy this and let's try to do v id mapped, this time is equal to that, and we'll just try to see what we have here. And I think we do not need to print v or value of v because we have unmapped them. We should have we should get an exception, a hardware exception, page fault, if we ever try to write to that. So here we are expecting to see that we could write to value. That's correct. And here we have a page fault. So our quick mapping and quick unmapping work correctly. What a relief. Well, that's pretty much it for this one. We have made great progress. There are still quite a few things to be done, but we are on the right track, and that's all that matters, right? As always, if you've liked this video, hit like, subscribe, and leave a comment, and until next time, I'll see ya. Falcon out.